In this video, we're going to talk about linearization and linear approximation. So linear approximation is very similar to this problem that we're about to do. So we have this intro problem. Let's just go ahead and do it. It says find the equation of the tangent line to f of x equals x to the fifth at x equals 1, then use it to approximate f of 1.1. So first we want our tangent line. We need two things in order to get a tangent line. We need a point and we need a slope. They've given us the x value for the point, that's 1. The y value to the point I'm going to get by plugging 1 into my f function. That's going to be 1 to the fifth, which is 1. To get our slope at x equals 1, we need to take the first derivative. So my derivative of x to the fifth is 5x to the fourth, and then plug in 1, and we get 5. So I can write the tangent line equation y minus 1 equals 5 times x minus 1. That's our point slope form. And then I'm going to add this 1 over to the other side. And I'm going to say this is my equation of my tangent line. We could have used the one above, doesn't really matter. But then it says use it to approximate f of 1.1. So I'm going to say f of 1.1 is approximately what I get when I plug 1.1 into this x. So I get 5 times 1.1 minus 1 plus 1, which is 5 times 0.1 plus 1, which is 0.5 plus 1. So we get 1.5. That is our approximation. And I'm actually going to say f of 1.1 is approximately 1.5. Okay, so let's look at what we did on a graph. So over here, this red is the graph of x to the fifth, and then the blue line is our tangent line at x equals 1. So what we do for linear approximation is we say, if I look close to this x value, my line is very similar to my curve. We approximated f of 1.1. 1.1, I'm following with my arrows right here. So we found the point on the tangent line. Notice it's very similar to the point on the curve. So that is what we are going to be doing. We're using that line to approximate a value on the curve. The terms in this section are linearization and linear approximation. And we have a formula for linearization. But I want to point out that this formula is just the equation of a tangent line. So I never recommend to my students to memorize this formula. This is your slope, just like we have here. My x minus c right here is just this x minus 1. And then this f of c is just the f of 1 right here. So I would say as long as you know that linearization is the same thing as saying find the equation of the tangent line, you do not need to memorize this formula. This is just a tangent line. And then they can ask you to use your linearization to approximate some other f of some other x value on your curve. And when you do that, you're just plugging that value into the x in your linearization. So here they're plugging in a. And that is linearization and linear approximation. We're finding the equation of the tangent line, and then we're plugging in a number. So let's see a couple of questions that they might ask us. It says, find the linearization of f of x equals cube root of x at x equals 8. Use a linearization to find an approximation for f of 8.1. So I want the equation of the tangent line for f of x at x equals 8. Let's start with that. Just like before, we're going to get the point and we're going to get the slope. The x value of the point is 8. To get the y value, I'm plugging 8 into my f of x, and I get 2. For the slope, I need the first derivative, Keep in mind that your f of x, you can rewrite it as x to the 1/3. So my first derivative is 1/3 x to the negative 2/3, or 1/3x to the 2/3. Plug in 8, we want the slope at x equals 8, times 8 to the 2/3. Okay, and then this is the cube root of 8 squared. Cube root of 8 is 2, 2 squared is 4, so I get 1/3 times 4, which is 1/12. So that is my slope. I'm going to write out my point slope form. Y minus 2 equals 1/12 times x minus 8. And then to get it in their form, all I need to do is add the 2 over to the other side. And then I'm just going to say L of x, because that's what they were using, equals this 1/12 times x minus 8 plus 2. So this is your linearization. Notice we found the tangent line and then we added the 2 to the other side. They said use the linearization to find an approximation for f of 8.1. So now I'm going to say f of 8.1 is approximately L of 8.1, and I'm going to plug that in. This is going to be 1/12 times 0.1 plus 2. 0.1 is 1/10. So I get 1/120 plus 2. I can write this as 2 and 1/20. Or I can get common denominators. 120, 240, or 241/120. And we're going to say this is approximately f of 8.1. And then as a side note, just to show you, if I plug this into my calculator, I get 2.008333. If I plug the cube root of 8.1 into my calculator, I get about 2.008299. So notice that these are very similar. Now you might ask, why would we need to do this? Notice that we were able to do all of this work without a calculator. So if we don't have a calculator, this is a lot easier than figuring out the cube root of 8.1. We have one more problem. Example 2 says approximate 2.01 to the 5th using linearization. So notice here they're not giving you an f of x. They're not telling you to find the linearization at a certain x value. So here you need to decide what is your f of x, what x value are you finding a tangent line at, and then we'll use that to approximate 2.01 to the 5th. So I'm going to rewrite this. I'm going to say find the linearization of, and we need to choose an f of x. Now, I have a number raised to the 5th power, so I'm just going to say f of x is x to the 5th. And it's going to be hard to find a tangent line at 2.01 because I'd have to do 2.01 to the 5th, and I'd have to plug 2.01 into a derivative. So let's say at x equals 2 because that's close to 2.01. And let's use that tangent line to approximate f of 2.01, which will be your 2.01 to the 5th. So they're not giving you any of this info, but you need to come up with it. So we need to find a point and a slope. Notice at this point, this problem is very similar to the previous one. My x value is 2, my y value is 2 to the 5th, which is 32. For the slope, I need to find a derivative, first derivative, and I need to plug in the x value, which is 2. I get 5 times 16, which is 80. So y minus 32 equals 80 times x minus 2. I'm going to add the 32 over to the other side. And I get L of x equals 80 times x minus 2 plus 32. So there's our linearization, and we're going to use that to approximate 2.01 to the fifth. I'm going to say 2.01 to the fifth is approximately L of 2.01. And we're going to plug it in for x. I get 0.01. 0.01 times 80 is 0.8. And we get 32.8. So I get 2.01 to the fifth is approximately 32.8. And that would be our answer. And then just as a side note, if I do 2.01 to the fifth in my calculator, I get 32.8080401. So we're pretty close. And those are a couple of examples of linearization and linear approximation. Thank you for watching.